All right, logicians. So I want to talk you through another example of how to use indirect truth tables in order to determine the validity of an argument. So here's our argument: premise 1, premise 2, conclusion. Now you remember, when we're using an indirect truth table, what we're looking for is a line of the truth table, a set of values for the simple statements, which, when you plug them in here, will give you a true premise, and a false conclusion. If you can come up with one of those combinations, if you can come up with a set of values that give you all true premises but a false conclusion, then what you've done is you've shown that that argument is not valid. You've given a counterexample to the validity of the argument. But if you show that no such combination exists, it's not possible to come up with values that will give you all true premises yet a false conclusion, then you've shown that the argument is valid. So you're looking for counterexamples to validity. Now, that counterexample has got to be one where, here's our main operator, where this turns out to be false. Right. This one turns out to be true, and this one turns out to be true. Okay, so you can start your working on the indirect truth table from any one of these lines. But what you're trying to do is you're trying to come up with the easiest way to derive a counterexample. In other words, you want to look for the main operator that has the fewest possible ways of giving you the value that you need. So for example, here we need the horseshoe to be false. That's what we're looking for. Well, there's only one way that a horseshoe, a conditional statement, can be false, and that is when there is a true antecedent but a false consequence. On the other hand, there's two different ways for a triple bar to be true. It's true if either things on both sides are true, or if the things on both sides are false. So there's two possibilities. And then there's three different ways for a conditional statement for a horseshoe to be true. So the easiest, fewest options line that we have here is the conclusion. So we're going to start there. We're going to make the horseshoe to be false, and in order to do that, we need the antecedent to be true and the consequent to be false. Okay, so in order to get that, P is false. We're going to plug that in here. Not R is true, which means that R itself has to be false. So we know that R is false. Now what we want to do is plug that in and see if that possibly makes one of these to be, that makes these to be true. So we'll start here. So we know that P is false. We know that R is false. And that means that not R is true. Now right there, already, even before I work through all this stuff, I already know that this line is true. Why? How do I know that? Because the consequent of the conditional is true. And the only way to make a horseshoe, a conditional, false is if you make the consequent false while the antecedent is true. So I already know that because the consequent is true, this whole line, horseshoe, is true. That's a T. All right, so now the only question is there any way that I can make this line true given these values? Well, I know that, actually I don't know anything about what Q and S are. So that means there's multiple possibilities here. Is it possible that I could have P and R be false and thus this line be true and this line be false while, let's say, both of these were true? Well, if both of them are true, then the negation of both of them is false. And if both of them are false, then triple bar is true. So bingo, there you go. I've got a counterexample right there that shows this argument's not valid because I've got a combination of possible values that makes both these premises to be true while the conclusion's false. There's another possibility though as well. I only need one, but if I flip these and made both of them false, I think I meant to, no, I did that right. Q is false, and S is false. That means not S is true, and not Q is true. That also would make this line triple bar to be true. So, there's multiple possibilities here. Right. In any case, you only need one to show it's not valid. But our basic strategy is we're trying to see if it's possible to come up with a set of values that makes premises true and the conclusion false. And if you do, then you've shown that this argument is invalid.